Hello, everyone. Welcome to week 7 and chapter 7 in our new book. And the chapter is called The Time Value of Money. I hope this week finds your families and you happy and healthy, and that you are finding your workload is reasonable. And as always, I encourage you, if you have questions, to please give me a call or send me an email and let me help you. Uh, I'll be more than delighted to do that. This week's topic, the time value of money, is a really important topic for us to understand as public finance administrators. It's also, for some of us, a challenging chapter because this requires us to put on our hats as mathematicians and to use some basic math concepts that for some of us can be a real challenge. I've never been really good at math myself. I've been fine at math, but I don't enjoy it. And as a result, I have to spend extra time working through doing math problems and issues. I hope that you find that that's not as much a challenge for you. But as a result of, and the reason that I mentioned that I am sometimes math challenged, that's why I became a lawyer and a corporate executive, um, is that when I do have topics like this to talk about, I try to break them down as simply as possible and to go through step by step. And I hope that in talking about the time value of money with you today, you'll be able to follow through. We're going to follow through easily and understand what I'm talking about. We're going to use examples from the book. I'm going to refer to the book so that it's easy for you to track back and forth. And, of course, push that pause button here whenever you can. And if you have questions, let me know. In public administration, we will often look at investing in alternative projects. And so we have to consider when there are competing projects or programs that we need to fund or invest, we have to look at which one of these might provide the greatest benefit or the greatest value to the organization, or more importantly, to our stakeholders, our citizens. And so we use these concepts called future value and present value to perform an analysis and help us to determine these values, and the values then help us to weigh which projects might be more worthy of our investing. Your textbook shows many examples of how financial decisions are based on analyzing the value of investments and the value of payments. And a lot of these examples are going to be beyond the scope of what we want to talk about here in public finance administration. We will talk about several of these when we get into this book in the Principles of Finance class, if you haven't taken that class already. So getting a basic understanding will help you in the future for that class as well. I want to help you understand a few concepts first, and then we'll get into how we calculate these values so that you can be a better public finance administrator and use these to make the best informed decisions possible. When we talk about time value, this is a method of expressing the present value of something in the future. And what we do something called compounding. We add interest to it to see its value. Or we take something that has a future value, something we know will be worth something, say, in 10 years, and we look at what the investment needed today would be to get to that future value. And so we take that future value and we discount it backwards to what those dollars are worth today. in today's investment. And that's the nature of expressing time value. We use certain tools when we calculate time value of money, and it will be helpful for you to have your book available, maybe to have a calculator with you and some paper to write things down. And later, we'll look at some software programs that you can use to do these calculations. In fact, if you haven't taken the Excel class that's taught, I think it's Administration 195 maybe, that's a class that may be required for our major. The Excel program has ways to help you calculate these more easily. But if you can understand step by step how these work, you will be in a much better position and have value added in any public administrative position to be able to explain and express these calculations so that you can make better decisions. There are certain variables and certain vocabulary that we're going to use when we talk about time value of money. And you'll see these acronyms or these abbreviations as we talk about these things. So it's important to get comfortable with these key variables. PV means the present value, what money is worth today to get to a point in the future. Future value, we'll say, is FV. A payment is an annual payment, generally made once a year. In the examples we're going to look at, we'll look at something simple based on annual payments. And then we will look at the number of time periods that we make those annual payments. So do we look at these payments over a period of 5 years? That the N would be 5, the number of time payments. Do we make payments over 20 years? N would be 20 to represent the number of 20 different payments. And then the little I stands for the interest rate that we're going to use, because money that's invested should get a rate of interest, should be able to grow, and we need an interest rate factor to calculate. And these will be more clear as we work through some of these examples. When if you use a financial calculator and even basic calculators, we can put these kinds of values in, and the calculators will calculate these. And at some point when we have face-to-face meetings again, we can take a look at these, and I'll show you some of the examples that I've used with some of my calculators. Let's start first now with talking about future values. We're going to work through an example that begins in your textbook on page 83. Okay, so it'd be a good idea for you to turn to page 83 of the book. I've replicated many of the concepts onto the PowerPoint slides here, so you can follow along and go through with the PowerPoint slide once again to just have a key understanding. And so let's start with the idea of future values. All right. Let's say that you have $100 and you want to know what's that $100 worth in the future based on it earning a certain interest rate, right? So in the example on page 83, starting on page 83, we see that our example is we deposit $100 into a bank, and we assume that we are going to get a 5% interest rate on that investment, on that deposit in the bank. So what's the future value of this $100? After 1 year, it would be the payment, $100, times 1 plus the interest rate, 0.05 is 5%, in the first year. Number of years, 1. So payment, 100, times 1.05 equals $105. Take a pencil and paper, write that out. Make sure you have a clear understanding of step by step, left to right, how this works. You can see the example in your book on the middle of page 83, where the principal after year one is $100 plus 5% or $105. Let's take it a step further now and say that we want to know the value of this money after 2 years. Well, after 2 years, we would have to do two of these calculations. We have a year one calculation of 100 times 1 plus 0.05 to the first power, which is then gives us the value $105. But then beginning in year two, we use the value $105 right here. So in year two, it's $105 times 1.05 plus 0.05. And that value then is 105 times 0.05, which is $5.25, gives us a total of $110.25. Let me say that again and you can write it down, okay? 105 plus 1 times 0.05 is the value at the end of year two. 105 plus 5.25 equals $110.25. Now, to get the third year, we would do this calculation once again for year three. Here we would take $110 times 1.05, and that equals then $115.76. $110.25 plus the interest, $5.51, equals $115.76. So to answer our question, $100 invested today would in 3 years be worth $115.76. We'd have to do 3 separate calculations in order to get that. If we wanted to figure this out for 20 years, we would have to do 20 years calculations, working the formula out like this. That doesn't sound very efficient, does it? Now notice, before we explain how to be more efficient, notice that we earn interest on interest every year. So every year our new principal or payment amount changes because it's $100 plus the end of the year's interest. Year two, $105 plus the end of the year interest for year two, etc., etc. That interest upon interest is called compounding. Compound interest is the interest that is paid over particular time periods. In this case, we're using annual interest. But in reality, in the real world, interest can be compounded and calculated every quarter, every month, twice a year, even every day. We can have compounded interest. And so doing a calculation like this to calculate the future value of some money today that we want to invest can be a not difficult, but tedious process because we have to make calculation after calculation after calculation to get to that end amount. So you could calculate the future value year by year like this, or instead we can use what's called an interest factor table. Take a look in your book at Appendix A on page 537, I believe. 537, yes. Just if you got to the right page, you're going to see Appendix A shows us the calculating the interest factors for a future value, and on the next page we see what's called, backwards here, so figure this out in a way that you can read. Um, we calculate these interest factors. This is a table in which factors or some calculations have already been made for us. So instead of going step by step by step to calculate the value of $100 in 3 years, or let's take another case here and say in 20 years, we can use this interest rate table. The way you do this is as follows. Down the left-hand column is the number of years. If we're going to calculate n equals 20 years, go down to the row marked 20 for year 20. Then we choose the column that's connected with the interest rate that we are assuming. And in this case, let's assume an interest rate of 5%. So 5% into the column that says 5%, matched with the row that says 20 years, gives us an interest rate factor of 2.653. Everyone see that? 2.653. Now, instead of going line by line by line, we can simply take $100, multiply it by 2.653, and that will tell us the future value of $100 at an interest rate of 5% in 20 years. If we invest $100 for 20 years at 5% interest, we can expect that to give us $265.30 at the end of year 2. Now, if you use these interest factors, you see that the factor gives us 265.30. If we use the line by line, step by step, we'd actually get a slightly different calculation. We'd get $265.33. Why? Well, because these interest rate factors round off to the third decimal place. And that means that we lose a few cents by the rounding factor here by using interest rate factors. But notice how much easier it is for us to calculate future values. If we have a certain amount of money today, how much will it be worth in a certain number of years based upon a certain interest rate? Future value grows based on time, right? The time invested and interest earned. How much interest was earned on this $100? Well, we would take 265.30 or 33 minus 100 tells us the amount of interest that was earned over 20 years. In this case, it would be $165.33 is the amount of interest that we've earned. The principal, the amount we invested, never changes, right? It's $100. That's how we make a simple future value calculation. Let's go next to calculating present value. Let's say that we expect or we want to have something of, or let's say we have a future value we expect in several years that the value of a project is $100,000. How much money do we need today to create that project based on a certain interest rate or interest factor? And the way that we do that is by calculating what's called present value. Present value calculates how much money we would need to invest today in order to get an amount in the future, assuming a particular interest rate. So, for example, if we want $1,000 in 20 years, how much money would we have to invest or put in the bank today in order at an interest rate of 5% in order to get that $1,000. The calculation we can find. Let's see if I can find it in your book. What in chapter 7? Let's go to the page where this calculation is done, and that calculation is on page 87. Page 87. And you'll see that the calculation is that our present value equals the amount over 20 years divided by 1 plus the interest rate over 20 years. Again, if we did this longhand, we would have to do this calculation for year 1, year 2, year 3, year 4, all the way down to year 20. And if we did that, we would come up with a calculation that says a little over $377 today would grow to $1,000 in the future. But that's a challenging process for us. So instead, we can go to the back of the book to Appendix B, and in this case, we look at the interest factors for present value, and we calculate the present value based upon the number of years that we will have the investment and the assumed interest rate. So here, if we have want $1,000 in 20 years at an interest rate of 5%. Let's see. I'm just checking to see, did I make an error in my PPT here? Yes, I did have a calculation error here, and so I've just made that change. If we want $1,000 in 20 years at an interest rate of 5%, what's $1,000 worth today? If that $1,000 20 years from now, what's it worth today? And we can use the interest factor table on page 539, again looking down the first column for the number of years, 20 years, then go across the column to find the interest rate of 5%, scroll down to 20 years, 5%, and we use the interest rate factor 0.377. So in a fast way to calculate the present value, the value today of $1,000 20 years from now, is 1,000 times 0.377, or $377. If we put $377 into the bank today and let it grow at an interest rate of 5% during the next 20 years, we will see it grow to $1,000. We need $377 to get to that $1,000 in 20 years. And why does it grow? It's through the process of interest compounding, that we get interest on interest, and that helps the money to grow. These are important calculations for us. Future value is important for us to calculate because as public administrators, we want to look at what interest rates may be in the future, what we expect. We might want to look at different time periods for which we are going to make in the investment or borrow money. And the same thing for present value. These interest rates and time periods influence how much the present value will be. It may be higher or lower depending on these variables that we use. Any questions about present value? In public finance administration, we could often use present value calculations to compare maybe 2 or more projects with different future values. And assuming the same interest rate, we could see which project we would want to fund, or assuming different interest rates and different time periods, we might want to figure out or see which project would be a wiser investment for us. So we use present value and future value to help us make better informed investment decisions for projects and programs. The next calculation that I want you to understand is called the future value of an annuity. Now, an annuity here, what that means is that we don't make one payment like we did with future value. We make annual payments. We make a payment in year 1 or year 2 or year 3, all the way to whatever the end year is that we are calculating. So the future value of an annuity is a way for us to calculate how we would invest or contribute certain amount of money each year over a period of years, and then what that future value of the project would be worth. And this helps us again to compare projects and estimated returns or values compared to maybe just borrowing the money from the bank. And so how do we calculate the future value of an annuity? Let's use your book again. Page 90 of your textbook. We'll use the example that they show here. And there are two different kinds of annuities. One is what's called the ordinary annuity, and the other we'll call an annuity due. An ordinary annuity assumes that we don't make a payment in the first year, but we make a payment at the end of the first year, at the end of the second year, at the end of the third year. And so during this first year, there's no interest earned. On the other hand, the future value of an annuity due means that we make the payment or the investment at the beginning of the first year. So at the end of the first year, we will have interest. At the end of the second year, we will have interest. And at the end of the third year, we will have interest. And that's the key difference between the future value of an ordinary annuity and the future value of an annuity due. Again, we can use long-handed calculations. You could see on the middle of page 90 of your book, the future value of an annuity due, or towards the bottom, the future value of an ordinary annuity. Those are examples 7.5, 7.6 in your book, shows that you would have to make a number of calculations in order to get to this. Or we can use the interest factor tables at the back of the book to calculate the future value of an annuity. Now, the future value of an annuity interest rate table is made based on the future value of an ordinary annuity, assuming the payments are made at the end of the year. Let's work through that example first. The future value of an ordinary annuity. In this case, the time value of money is based on when the investment is made. And in this case, the investments are made at the end of year 1, the end of year 2, the end of year 3. A long-handed calculation would get us to a value of 100 times the interest rate factor over 3 years at 5%. And what's the interest rate factor at 3 years at 5%? The interest rate factor is 3.152, right? So 3.152 times 100 means that $100 invested year after year for 3 years will equal $315.20 at the end of year 3. let's say we want to calculate this as not the future value of an ordinary annuity, but the future value of a um, annuity due. In this case, a future value of an annuity due requires us to basically just take the interest rates not based on 3 years, but assume four periods, because the beginning period, period zero, is when we make the first investment, and then the last period is the end of year three. So we could take $100, assume 4 years at 5%, calculate out. No, I take that back. I'm sorry. Okay, instead of using the interest factor table, we have the future value of an ordinary annuity is 100 times the interest rate factor of 3 years 5% point or 3.152, and that gives us a future value of an ordinary annuity of $315.25. If we want to calculate the future value of an annuity due, FVAD, let's make that a little bit bigger so it's a little more readable here. Future value of annuity due is going to equal, we'll take the interest rate factor, 3.152, and we multiply that by an additional year, one plus the interest rate, and that will give us the future value. So here the future value is 3.152 times 1 plus 0.05 is the interest rate, or 1.05. 3.152 times 1.05 equals $331.01. That's the future value of an annuity due, as opposed to a future value of an ordinary annuity. There's our we take the interest rate factor times 1 plus the interest rate. Any questions about how this works? Just go step by step as I've just described and try to do that for yourself. All right. How do you we simply do this multiplication. Why is this important to us? A future value of ordinary annuities or future value of an annuity due in public finance administration? Well, we can see what kinds of investments or what kinds of payments over a number of years would be worth, what their value would be when we compare alternative projects. And again, this helps us make more informed decisions. The last example I want to show today is the present value of annuity. Let's say we have a project we anticipate will have a future value of a certain amount, and what is its discounted worth or value today? Now, you could use the long form formulas found in your book on page 90 page 93, but instead let's just use the interest factor table found in Appendix D on page 543. So let's assume again that we use a present value of an ordinary annuity where payments are made at the end of the year. We use the interest factor table on page 543 to calculate what these future payments over time would be worth at today's value. And then that the factor discounts the value into today's value. The simple formula is payment times interest factor equals present value. So for example, if we want to make annual payments of $100 for 3 years, and we expect a 6% interest rate, and with ordinary annuities, we make that payment at the end of the year, then we look at the interest factor table. We look at 3 years on the interest factor table. We look at 6%, and we see that the interest rate factor is 2.673. $100 times 2.673 is what the future value is going to be, $267.30. So the present value of those 3 payments, $100 each year, $300 total, is going to have a present value today of $267.30. That tells us then $300 minus $267.30 is the interest that we will earn at 6% over 3 years. That's how much money we would earn in interest. So that's the present value of an ordinary annuity. Now, again, if we want to calculate an annuity due, we would take that same formula that we just looked at here, and we would apply the interest factor times 1 plus I to get the present value of an annuity due by adding that extra year. So in this case, I want you to work through, and I'll give you the numbers here. Write these down. The interest factor was 2.673 times 1 plus 0.06 equals what? 2.673 times 1.06 gives us an interest rate factor of 2.833. Multiply that by 100, and that gives us our present value of an annuity due. How do we use this in public finance administration or in public administration positions? Well, again, if you want to understand, say, the present value of lease payments on a property, or if we want to buy some equipment and borrow the money and lease it, we can ask the question what that present value of all of those future payments is worth today, and make better decisions in how we use our budgets and how we use our cash in public administration or in public finance. Those are the 4 key values that I want you to be able to calculate. In your textbook, there are lots and lots of examples of calculating these present values, future values, and present value, future values of annuities. And they begin on page 107. I really encourage you to read through some of these just to see how these real life situations use calculating present values and future values. One example that's often used is calculating loans or mortgages. So if we want to maybe borrow money to take out a loan for a project or a program, we can calculate the value of that loan and the annual payments, what they are, by using these simple mathematical tools to be able to calculate them. Those are the key points that I want you to understand for this chapter, chapter 7. As a homework activity, not too difficult here, I've chosen 4 problems in your book on pages 102, 103. Problems 1, 4, and 5. I'd like you to read the problems, do the calculations, write them out, then type them up and submit your answers to me in the discussion questions upload menu or link in the week 7 homework folder on Moodle. I'll try to change the name of the week 7 folder from discussion questions to problems, so it's easier for you to find. But that's where I want you to hit the link and upload your answers to these problems, and that will be the homework assignment for this week, week 7. Hope I didn't make this too confusing for you. These are really important formulas that we use in lots and lots of elements of administration and finance. And so these are key formulas and key calculations that you need to understand for lots and lots of business purposes. And I hope that these problems will help you to feel more comfortable with how to use those. As always, if you have any questions at all, be delighted to answer them. Give me a call or send me an email message, and I will return the messages as soon as possible. I want to mention one thing from the previous PPTs that I posted in the week 6 folder with the reviews of chapter 1 to 6. You'll notice at the very last PPT, I actually listed all of the homework assignments. And so it'd be a good idea for you to go to that last PPT in the week 6 folder, the PPTs for chapters 1 to 6 review. Go to that last PowerPoint slide and you'll see all these homework assignments listed, so it makes it easier for you to remember and know what homework I've assigned in each of these chapters. Hope you all are doing well in week 7. I'm here in the office this week and working on getting some of your homeworks graded this week, so you'll finally see some grades. I will also be trying to call you during this week if I haven't heard from you about scheduling a Zoom meeting. I really need to talk to you folks. And so expect a phone call from me. And if I call and it's not convenient, just tell me what a convenient time to call you back is, or we can connect on email. Hope families and everyone is happy and healthy. Good luck with all of your work this week in your online courses, and I will speak with you and hopefully see you soon. Bye-bye.